Okay, so this should be the first video for Algebra 2. Okay, the regular Algebra 2 class, not the Alex class, but the regular Algebra 2 class. So where we left off on Friday was on section 3.2. We were working on properties of rational exponents, okay? So we were covering problems like this. And now what we're going to do is move on from this kind of idea and actually go to properties of radicals, which is just a little bit harder, but it's not too much harder. So the way we're going to run this, okay, we'll pull it up, make the screen as big as you possibly can, and just kind of follow through. Feel free to hit that pause button anytime people need a little more time, okay? Because I'm probably going to be cruising through this. Usually, it's if it's me doing it by myself, I go a little bit faster than I do if I have somebody in front of me asking questions and whatnot. So if you guys have questions, make sure you ask Mrs. T. She'll give you a hand. Um, she's fully capable of answering all of this stuff for you, okay, or at least finding it out. So help each other. Make sure you hit the pause button. Have a little patience, and I'll be back before you know it. So, okay, well, let's start with what the first. You know what I wanted you to do first after we left on Friday is I had a set of problems I wanted you to practice. They were right here. Okay, I was going to assign them for homework, but we just kind of ran a little bit late in one class. In the other class, we didn't run as late. So you guys were already gotten started on this. So why don't you take a look at this page? So page 176, numbers 3 through 13 odd. Okay, I want you to work on that in class for the very first day. So make sure you're familiar with some of those properties of exponents. Practice those problems. See how you did. I gave you the odd because the odd are in the back of the book. So that should help out with seeing if you got it right. Um, so try those problems now. I want you to get warmed up with those. However long it takes you is fine. If we don't get through this whole video today, that's perfectly fine. We'll just pick up tomorrow where we left off. Just resume where you were, okay? So that's the goal. So you work on these. Here's actual the answers. You know what? You should probably pause it right now and let everybody work on these, and then I'll show you the answers when they're done, okay? So go ahead and pause the video. Okay, so hopefully you're back. So you hit the play button, now you're back, and you want to see the answers. So I've got the answers right here for you. Okay. Sorry, Monica, they're in that pink color, which you can't see. So ask Kayla to tell you what they say. Okay. So you can zoom in on this if you have to. I'll try to make it a little bigger. Let me see if I can make it any bigger for you. So maybe it's a little bit easier to read. Might have made it too big. Eh, maybe not. Yeah. Let's back it up a little bit. Hopefully that's a little bit bigger for you. Maybe that'll help in seeing what the answers are. So check those answers out. Depending on how you did, make sure you understand where you went wrong. You probably made a couple mistakes, and that's perfectly fine. Just make sure you check and understand where you went wrong. If you are struggling on any of these problems, check with Mrs. T, and she can kind of help walk you through where you might have messed up. Okay, or check with your neighbor next to you. Okay. Okay, so if you're done with that, I don't know what time it is in the period. You might be on the next day, you might not, but let's move forward with the next lesson. So the next thing we're going to start talking about here is properties of radicals. This would be a good thing to put in your notes right here, okay? So for your notebook, okay? Put these two laws in your notebook. So it's the product property and the quotient property, okay? So we've used these before, but now we're just going to be using them with bigger radicals, okay? So we're not going to be using them with, just square roots, but we'll be using with cube roots, fourth roots, all those other things, okay? So let's do a couple practice problems of what you see here. So down below, or number A, or number A, letter A, we have an example, the cube root of 12 times the cube root of 18, okay? So what we're going to be allowed to do according to the product rule, okay, product rule right here, allows me to take these two separate things and put them together as one, okay? So we're actually going this direction, I guess, if you want to think about it. All right, so that's going to be the cube root, and I'm going to apologize ahead of time. My writing's a little sloppy on this thing because I'm trying to, uh, you know, do it from my home computer. It's a little bit harder. Okay, equals this, and then So what that's going to be is it's going to be the cube root of 12 times 18. 12 times 18 is 216. You can use your calculator for that. And then we can work that out if it's possible because 6 times 6 times 6 is 216. So the cube root of 16 is just 6. Okay? And we're done. All right, so that's the product rule. Let's go down and try a quotient rule. Quotient rule. So you got two separate ones, like this example up here, and we're going to put them back together. You're almost always undoing them. Okay? So what I'm allowed to do here, what's legal, is make a big fourth root and put everything under it. So it's going to be 80 over 5. Okay? Well, then what's 80 over 5? Well, 80 over 5 is 16. So you got this fourth root of 16 because 80 divided by 5 is 16 equals um, 2. There you go. Because 2 times 2 times 2 times 2 is 16. So you're good to go. Okay? So there's that you're just simplifying. Okay? That's simplifying it. All right. So I'm sure we're going to need a couple more practice problems. So let's bump down. We'll try a couple more practice problems, and I'll let you try a couple on your own. Okay. So here you go on the next page. Why don't we try these two? And okay. So what we're going to do here, sorry, I had to pause it there for a sec, is we're going to try to do the cube root of 135 by hand. We're going to try to do this by hand without the calculator first. Okay, then we can work into the calculator later. Okay, so if we're looking at 135, all right, what you're going to want to do is try to find a cube root that multiplies by another number so you can break this apart. Because what we're going to do is we're going to break this into two cube roots. Okay, I'll give you a hint. We're going to break it up like this. We're going to have a cube root here, and we're going to multiply it by another cube root here. Okay, because I'm allowed to do that according to that product rule on the other page. So here's a cheat sheet I found. I just Googled it, and this is actually, it's like perfect. So if I were you, I would copy these down. I would pause the video, copy some of those down. That's going to be a great help for you because what you're going to need is to know what some of these numbers are. You're probably pretty good with squares. Cubes you might be a little bit shaky on. Fourth roots, fifth roots, those are even trickier. Okay? So you're going to pause the video. I would copy down at least what's in yellow. The white stuff, I don't know. That's you're typically not going to use those. I would just do the yellow for squares, cubes, fourth roots, and fifth roots. Okay. So go ahead and pause it. Okay, so we're back. You just got done copying down that table, and we're going to look at our problem. So I'm looking at the cube root of 135. So let's look at the cube root list, which is right here. Okay. What number can be multiplied by something to give you 135? So look at that list, see if you can figure out what it is. Did you find it? 27, right? All right, so you might have had to do a little guess and check on your calculator. That's fine. So this is actually going to work for us, okay? So we're gonna use that 27 because that's and I'll show you why that makes sense. So what is it going to be? It's going to be 27 times 5 will give you 135. So if I'm looking at my paper here, I'm going to go 27 times 5. So that's legal, right? That's a legal operation. All I did was break that apart. Well, why we picked 27, why we picked this value right here is because this guy is going to break down real pretty, okay? It's going to break down real nice. All right, so the cube root of 27 is what? 3, right? Okay, and then what about the fifth? A fifth root of, or the cube root of 5? Not going to break down. I want it in exact form, so I'm just going to leave it, and we're done. So just leave that there, and then you're done. That's all you can do with that problem. You can't break it down any further. But the key here was I was pulling the biggest cube root I could out. All right? All right, let's bump down to the next problem. Let's try quotient 1. So yeah, let's jump to a different color. I'm getting sick of black. So okay, so we're looking at B, and here I'm going to want to put it in a big square root, because that's typically, you're just going to usually want to do the opposite of what you see. So big square root of 7 over 8, right? So 7 over 8. So we're looking for, you know what? Let's scrap that. That might not be the best way of doing that. Let me see here. Okay, so hold on. Let's think about this though. Do I even want to do that? Is that going to do me any good? Is 7 over 8 going to be a nice fifth root? It's not. Okay, so maybe I don't want to do that. So you don't always want to do that. Sometimes you do, sometimes you don't. In this case, neither one of these numbers, the top or the bottom, will break down any smaller, right? Because there's no number that multiplied by itself is going to be 7, and no, or 5 times is going to be 7, and no number multiplied by itself 5 times is going to be 8. So there's not much you can do with this here. So it might already be simplified, but the problem here is what? Why is this not in simplest form? Does anybody know? Somebody knows. Yes, yes, very good. You guys are fantastic. There's a radical in the bottom, okay? We cannot have this radical in the bottom to be in simplest form, okay? This is a problem, okay? That we gotta get rid of that radical. So how do we get rid of that radical? All right. Well, what we're gonna want to do is multiply the top and the bottom by something to where it will be a nice fifth root on the bottom, okay? So let's think about what you know. Let's go to my list. I'm gonna go to my cheat sheet list here. Okay. I'm gonna look under the fifth root. What's a nice number that's divisible by 8? Okay, because there's an 8 on the bottom of my fraction that will be on this list. Ah, 32. Okay, so 32 will work. So if I can make the bottom of, let me get that thing out of there. If I can make the bottom of my fraction the fifth root of 32, then I'm set. Okay, because then that will just become 2. So how I'm going to do that is I'm going to multiply by something. I'm going to multiply by 8 by something to get to 32. It's going to be 4. So I'm going to multiply the bottom by the fifth root, okay, of 4. But if I do the bottom by the fifth root of 4, I have to multiply the top by the fifth root of 4. Okay, there's no way around that because I want this thing in the blue to be what? What's that value? It's ugly, but it's really a value. Ah, very good. I'm sure Steven said that. No, he probably didn't. Okay, that's going to be a 1, right? The thing in blue is red, or is 1. So if I multiply this thing in blue by my original expression, I didn't change the value. But what I did do is ra the fifth root of 8 times the fifth root of 4 is going to be the fifth root of 32. Okay? Now, if I do that on top, the fifth root of 7 times the fifth root of 4 is going to be the fifth root of 28. So now, why was that nice? Well, the reason that was nice is because we know the fifth root of 32 breaks down real nice. What does that break down to? Ah, very good. It breaks down to a 2 because 2 times 2 times 2 times 2 times 2 is 32. Now the top, will the top break down any? No, it won't. So we're going to leave it as it is. Now, is this in simplest form is my question to you. Yes, yes it is, because the top won't break down anymore and there's no radical in the bottom. So we're actually done. This is your final answer right here, okay, in purple. So there you go. So that one was a little bit tricky, but hopefully you got the hang of that. All right, so let's bump over. We'll try a couple more. Actually, you know what? Why don't you guys try these ones? Why don't you try these ones right here? So I'll pause the video, or no, you'll pause the video, and then I want you to try these three on your own, and then when you're done, we'll come back and we'll walk through them a little bit, okay? Okay, so we're back, and you tried these three on your own, hopefully, okay? So let's see if you got them right. Um, this one right here, you might want to think about putting them back together. Okay, so if I put them back together, would it benefit me is my question. So the fourth root of 27 times 3, well, this one I'm going to write it as. I'm allowed to do that, right? That product rule says I can put them back together. Well, why did I want to put them back together? This is why. Because that's really the fourth root of 81, right? Well, what's nice about the fourth root of 81? Well, if you're not sure, go back to your little cheat sheet here. Fourth root, 81. Ah, bingo. It's 3. Okay? So that's why we wanted to do that. So this whole expression is what? It's 3. You're done. Okay? So hopefully you got that. All right, let's try the next one. The next one, you got 25 or 250 over 2, and you might want to think about breaking down the top, okay? There's not much you can do with that bottom, but maybe we can break down the top because what I want to do is get this 2 out of here. But could I do it this way? Because you could have done it many ways, and like I said before, there's no one way of doing this. So any way you find a way that works is fine. There's multiple paths to the right answer. So let's try this. Let's go. What if I took the top and I broke it down like this? Cube root, okay, of 3, or the yeah, the cube root of 5 to the third power. Why am I going to call it 5 to the third power? What's 5 to the third power? Anybody know? 125. Good. Okay. Times 2. So what's 125 times 2? 250. That's the way I decided to break that down. On the bottom, you just got the cube root of 2. Okay. So can you see maybe where I'm going with this? Hopefully you do, because that top will break down again to what? Well, I can separate them. So the cube root of 5 cubed. And if you would have left that 5 cubed as 125, that would have been fine too. That wouldn't have been no big deal. Um, cube root 2, and then cube root of 2. Okay, so what do you see there? Hopefully it's glaring at you. It is. Okay. These are going to cancel. Okay, because they're the same. So what am I left with? Well, radical 3, or not radical 3, the cube root of 5 to the third power. Well, what's 5 to the third power? 125. So that just undoes, the 3's undo each other, and you just get what? 5. Okay? You could have also used your calculator on there if you were a little bit slick with the calculator. That would have been fine too. Okay, let's jump down to number 8. Let's see how we did on number 8. Okay, so number 8, let me give myself one more room. Okay, so if we're looking at this, I might want to think about breaking them up. Okay, so because there's not much I could do with 3/4. All right, so I'm gonna try breaking them up. And sometimes you guys are gonna try this, it's not gonna work, and you're gonna try something else, which is fine. Okay, because it's a guess and check process sometimes. Okay, now that would be simplified, but what is the problem? Why is it not simplified? Because of this guy, right? That's why it's not simplified. So what we have to do is get rid of it. How are we going to get rid of it? We're going to multiply it by something to where we'll have a nice fifth root number, like a perfect fifth root. So let's look at our cheat sheet again. On the fifth root side, what's a nice number that we can multiply 4 by to get one of these numbers here? 4 is divisible by which one of these numbers? 32, right? Good. All right, so let's try that. So what do I have to multiply the bottom by to get 32? 8, right? So if I multiply the bottom by the fifth root, this is almost like rationalizing the denominator. That's pretty much really what you're doing, okay? But it's a little bit different when you're using different numbers. So why did I do it on the top and the bottom? Because that's a 1, right? Yeah, the black thing is a 1. So by multiplying the top and the bottom straight across, the bottom is going to be the fifth root of 32. Ooh, bad 3, sorry. 32. And the top is going to be the fifth root of 24. Okay. So now, the bottom we know is going to be what? What's the fifth root of 32? 2. And the top is going to be what? Nothing, right? Because it doesn't break down nice. So you're just going to kind of leave it as it is. And you're actually simplified there. You don't have to go any further than that. Okay, that's as far as it'll go. Okay, good. So hopefully you did well on those. If not, we have more practice coming, so don't stress at all. Now, what we're going to move to next is addition and subtraction of these expressions, okay? So let's look at this. We're going to look at a couple of these examples, okay? Let me pause the video real quick so I can check something. So if we're looking at the first one, okay, and we're going to be adding them together. All right, there's a couple rules for adding them. They have to have the same ending. When I say ending, I mean they have to have like the same radical, and it has to be exactly the same. It has like you see how these two are the same? Okay, that means I can add their things in up front together. Here, let me show you what I'm talking about. I can add this guy and whatever this guy is together. Well, what's this guy right here? A one, right? That's a one here. I'll put a one in there just so you can see it. It's not there, but you know it's there, right? That's a one. So if you have one of these things in blue, and you're adding seven more of these things in blue, you can rewrite that as one, like the things out front, one plus seven times the fourth root of 10. So that's the same expression is equal to 8 times the square root or the fourth root of 10, right? So if you have one of these things and you add seven more, you have 8 of these things altogether and you're simplified. So addition and subtraction could be easier if they're already lined up for you. So there you go. That's 8. That's these things and you're done. Okay? So let's try this one. Now you know they can't all be that easy, but we'll start off easy. All right? If you're looking at this one, you got a 2 and you got a 10, right? But they have the same thing, right? They have the same thing. Here, let me highlight again. These are the same things, okay? So what I can do is I can rewrite this expression. I can rewrite this expression as 2 plus 10 times this thing, which is 8 to the 1/5. Because I didn't break any rules. I'm allowed to do that, okay? You can check it. If you FOIL this back in, if you distribute this guy back in, you'd be right back to where you started, so that's fine. Okay, well 2 plus 10 is 12 times 8 to the 1/2 power, and you're done. Okay, so that's just some addition and subtraction with exponents, but we'll do one with radicals as well. Okay, so this one, let's look here. All right, why can't I add like these things together? Because they're not the same thing. But what I can do is I can rewrite it. All right, maybe what I'll do is try to break this thing down, the thing in red. Okay, if I broke it down, can I do this? Let's try doing this. Let's see if it would even make any sense. Can I take the cube root of 27 or the cube root of 54 and break it up to the cube root of 27 times the cube root of 2? All right, so I broke this thing down in purple. Can anybody tell me why I did that? Okay, interesting thought. Who knows? All right, well, I'll show you why I did it. And then we'll leave this guy here. The reason I broke these two down is because what is this guy right here? What is that? That's a 3, right? Yeah. So that's why I broke it down. So check it out. Now I got 3 times root, the cube root of 2 minus, really there's a 1 there, cube root of 2. So now check it. We've got two things that are the same, and we're going to add them together, right? So same backside, same backside. So how many do I have? I have 3 here, and I'm taking 1 away. So if I have 3 and I'm taking 1 away, how many am I left with? I'm left with 2. I'm left with 2 cube roots of 2, okay? So keeping with my color code there, 2 of these. I'm done. That's simplified. Okay, that won't go down any further. All right, one last one for you. Let's see if you can do that one on your own. We'll do it. We'll do it together. Okay, Lan, go ahead. Okay, so we're gonna try to break this one down. If we're looking at this, right, we might want to try to break this down so we have a cube root of 5. Can we break 40 down so it's something times 5? Of course we can. It'll be 8, right? So Let's take this thing in yellow. I'm going to replace it with something like this. Can I do this? The cube root of 8 times the cube root of 5. And I'm going to add that to the cube root of 5. Okay. So what's nice about this thing? Why does that work out nice? Nice design problem because what is that really? At the 2. Right? So you got 2 times the cube root of 5 because 2 times 2 times 2 is 8. And you got a cube root of 5. Sorry, I'll get a little sloppy there. Okay, now let's keep things with things, right? Or, yeah, you know what I mean. Okay, so here you go. That's what the thing is, right? And how many of them do I have? Well, I have 2 here. I have 1 there, even though you don't see it. Okay? So if I add the things with things, right, I'm going to be left with how many things and what is it, right? All right, so let's fill in the dots there. How many things? I got 1 plus 2 is 3. And what are they? Well, they're cube roots of 5. That's what they are. Okay? All right, good. So that one's done. Make sense? Piece of cake? They're a little bit hard. It's going to take a little practice. So this is what you're going to do. I want you to try this with what's left in class, or maybe if it's not left in class, you guys can take it up tomorrow. It doesn't have to be homework, so I'll let Mrs. T make that call. If you feel like you got a hang on this, why don't you do it for homework? If you feel like you're a little bit iffy on this still, why don't you just do it in class? And if you don't finish it, come back tomorrow and finish the remaining problems, okay? So I want you to try this next, and then we'll move on to the next section. So make sure you understand this well. So it would be a good time to pause the video now, let them try it, and then I'll take down the curtain and you guys can see the answers because I got the answers right there. Okay, so go ahead and pause the video. Okay, and you're back, and here is your answers. Okay, so let me see. Is there anything more to it? I think there might be a little more to it. There you go. I don't think I can make that much bigger. That's probably about as big as it's gonna get. Okay. Oops. Okay. So hopefully you did well. Let me get my recording thing out of the way so you can actually see what you're working on. Okay, so there you go. Hopefully you did well. If not, go over these problems, okay? And we'll pick up on the next section tomorrow, okay?